Hello. So today, as we start our journey into geometry, we are going to start with a little bit of vocabulary. Normally, when you are speaking about a new topic, you need to know what certain things mean. And so the three basic building blocks of geometry are a point, which is a location that doesn't have a size, a line, which is a collection of an infinitely many points that extend forever in two different directions, but they don't have a height or a width or anything like that. They just are a collection of points that extend forever in two different directions. And then a plane is formed by infinitely many points that extend forever to form a flat surface. And using those values, we are going to be talking about building and making larger things that will be defined. So the undefined terms are those point, line, and plane. Defined terms that must be carefully defined, like segments or angles or triangle. Those are things that we will define. And then also, as we go through geometry, we will have some axioms or postulates. And these are concepts that will be accepted as true without proof. So an example of that would be like 2 + 2 is 4, okay? And that would be something that we accept as true without proof. And then theorems would be things that statements or conjectures that can be proven, and we use undefined terms, definitions, etc., to help us prove those theorems. And we also are going to have some algebraic properties that will be true for this topic as well. So as we start down this road, something we're going to do in class is say, okay, look at this chart, look at these pictures. Can you use the vocabulary or the paragraph they talk about, and can you put those into categories? And so we will be categorizing different things within geometry using certain rules and concepts. And so this is something that we'll work on in class. Another thing would be, okay, we've got to in math learn, what are the true things that we've got to kind of follow all the time? And then using those rules, how can we make progress in understanding, what we're trying to do, or how can we solve for X? What can we do? You did that in algebra. You learn to say, I can follow these rules and also move with purpose to find the solution to the problem that you needed to do. So if we talk about Katie's Pet Motel, and those are the parameters, the bullet points that are going to be true. So based on those bullet points, which of the bold items below can you assume are actually conclusions that are valid? And so if you pause the video and look and see, you will notice that this is true. Jerome will have a dog. That's true right there, that Katie charges 40 and then 30. And then that's true. And this right here, if you work through it, there are 6 dogs and there are 4 cats who stayed there on Friday. So being able to say what is true and what can I, assume based on those things will be part of what we're talking about this year in geometry. Okay, the next thing would be, there are 2 types of geometry that we're going to focus on this year. One is synthetic and one is analytic. And I think the main thing is that synthetic is older. Synthetic geometry is basically shapes and figures and items that we are going to be studying, and it's called pure geometry or Euclidean geometry. Euclid definitely did a lot to contribute to geometry, and those are examples of shapes that would be synthetic or Euclidean geometry. Rene Descartes came a lot later, and he came up with a Cartesian coordinate system where you would graph and plot points on a grid. And so as we look at shapes within geometry, sometimes we'll be placing them on a coordinate plane or grid, and then sometimes we'll be just talking about shapes with values for their lengths and measurements off the grid. And so, yes, you studied lines in Algebra 1, and you will in all the other algebras afterwards, but also this year we'll be focusing on finding the length of segments, whether they're on a grid or off a grid, working with shapes on the grid or off the grid as well. So we've got synthetic, which is without that coordinate plane, and then analytic geometry where we place things on that coordinate plane and then work with those shapes. All right, thank you. Have a good day.